Okay, continuing on with our geometry semester exam. This is page 3, number 9. Determine whether each statement is true, below is true or false. This is not multiple choice, so we have to answer each one. Parallel lines meet at exactly one point. That is false. Parallel lines never meet because they're parallel. They have the same, they have the same slope. Okay, B, an angle bisector creates two congruent angles. Yes, any bisector, segment or angle, cuts a segment or an angle in half into two smaller equal halves. So that is true. I'm going to circle it. That is true. C, corresponding parts of congruent triangles are congruent. Yes, that is true. We literally have a theorem named after it, CPCTC, right? If two triangles are congruent to each other, then all of their corresponding parts are congruent. Corresponding parts of congruent triangles are congruent. D, supplemental angles have a sum of 90 degrees. That is false. Supplemental angles have a sum of 180 degrees. Complementary angles have a sum of 90 degrees. So that one's false. And E, the altitude from the base of an isosceles triangle creates two 90-degree angles. An isosceles triangle has two congruent legs and a base, and the altitude is the height from the base to the top of the vertex, and it is perpendicular to the base, which means it creates two 90-degree angles, so that is true. All right, number 10. This question looks different on your paper. It's the one on constructions. It actually had, I think, A, B, C, D, E, F, and you guys only have to complete A, B, and C, and they slightly changed C. When I went on the answer key earlier to check everything, they had this modified. So they decided that you didn't actually have to know as much about constructions as they had originally planned. All right, so A, and on your test for the review, you are not going to have to create any constructions. You're just only going to be looking at pictures like this and telling what the construction was made for, right? So identify the following constructions. Here, we have these two circular lines, right? So we took a compass and we placed it on a vertex and we created a kind of semicircle. And we took our compass, kept it the same measure, placed it on this vertex, this endpoint, and created another semicircle. And where they overlapped, we created an endpoint. We did the same thing here. Put the compass on one side, made a circle, put the compass on this side with the same measure, another circle, where they overlap here. And if we connect those two dots, well, that was not a straight line, but it was supposed to be. If we connect those two dots, that line cuts this segment in half into two smaller congruent halves. So this line that we created bisects this line that we started with, this segment that we started with. So this is a segment bisector. All right, for B, we have a picture here of an angle, and our little circular lines go through here. And then also we have a couple here that intersect to form this point, right? So this was created, we have an angle with a vertex. We put a compass here on the vertex and we kind of set it apart and we made a mark of a circle, right? So where that circle intersects our original angle here, we have 2 points of intersection. Then we put our compass on one of the points of intersection and created another circle, and we put it on the other point of intersection and created another circle. And where these two circles intersected, this dot, we drew a line through the vertex and this dot here, this point 3. So this line is what we created with all these little circular drawings. This was our construction. So our original angle is just this black angle. This line right here is an angle bisector. It cuts this big angle into two smaller congruent half angles. So this is an angle bisector. All right, and then finally, for C, we have these two. This is slightly different from the C that you've seen on the review that I posted. They look the same, right? So we started off with an angle. We put our compass here on the vertex, and we made like a little circular marking here, right? And this created a point of intersection here and a point of intersection here, and then they drew a straight line to connect the two. That created a triangle, right? Here, it looks like they did the exact same thing. Vertex here, circular marking, connect, oops, that wasn't a very straight line, connect the two endpoints, those 2 points of intersection, and these look like congruent triangles. So this is one way to create congruent triangles from congruent angles, right? Congruent angle marking. So this is going to be congruent triangles. All right, and then number 11. Here it says the isosceles triangle shown is placed on a coordinate plane with the y-axis as its altitude, which means this is our y-axis, right? If it kept going, we'd put a y here. And then find the length of AB and the location of point B if the coordinates of A are negative 3.2, 0. So it looks like the base of this triangle is the x-axis. Right? So like if we had a coordinate plane here, y-axis, x-axis, we drew this triangle just like this. Looks like a big Christmas tree. The middle of it is the y-axis, and then the base goes along the x-axis. So it's saying if this point is at negative 3.2, 0, where is this point and what's the length of AB? Well, the altitude is a perpendicular bisector of the base, right? It joins up at 90 degrees and it cuts the base in half. So if this is our origin, this dot right here, this is at 0, 0, and we went back 3.2 units to get to this point A, that means the distance here is 3.2. And if this is half of our entire line, that means this distance has to also be 3.2 units. So what's the length of the entire AB? 3.2 plus 3.2 equals 6.4 units. That's the length of AB. And then what's the location of point B? Well, if we went back 3.2 units to get to A, we have to go forward 3.2 units to get to B. And then this base here is on the x-axis, so we go up or down 0 for both points. So A is negative 3.2, 0, B is positive 3.2, 0. All right, and then also on your original paper, you had number 12. It got pushed off on this new print version. So I'm going to do that one real quick. It looks like this. Graphing points A, negative 1, 2, B, 1, 8, and C, 5, 2. Find all possible coordinates of point D so that ABCD is a parallelogram. All right, so we're going to, let me draw this a little darker. I'm probably going to make it look different. My printer was not printing good ink. All right, and then there are little markings on here. I'm gonna go ahead and make my own. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, blah, blah. Okay. And this is our y-axis, this is our x-axis. So first off, I want to graph the 3 points that it does give me, right? So A is at negative 1 up 2. Backwards 1 up 2, there's A. B is at over 1 up 8. 1, 2, 3, 4, 5, 6, 7, 8. There's point B. C is at 5, 2. Over 1, 2, 3, 4, 5, up 2. 1, 2. So here's C. So this has to make a parallelogram, right? And it says find all possible coordinates of point D so that ABCD is a parallelogram. So we're either going to come up with some point around here somewhere, something over in here, or we could actually come up with a point somewhere down in here, right? Because either we could have this parallelogram this way, or we could have this kind of elongated parallelogram, right? So first thing I want to do is connect the sides that I have. I know AB are going to connect and AC are going to connect, right? Or they can, they don't have to. All right, so if these connect, then I know B has to connect to point D, C has to connect to point D has to be somewhere in here, right? So excuse me. So the line in a parallelogram, lines across from each other have to be parallel. This is a horizontal line since A is up 2 and C is up 2. So B has to be a horizontal line as well. So the height of B is up 8, so I know D is going to have to be somewhere up 8. So D is going to be something, comma, 8, because it has to be horizontal with B. So then I need to figure out how far over D is going. Goodness, got my allergies. So I need to look at the relationship here. This line over here has to have the same slope as this line, right? So to get from A to B, what's my rise over run? It looks like to go from A to B, I have to go up 1, 2, 3, 4, 5, 6 units, and I have to go over 2 units, right? So I need to do the same thing from C to D. I have to go up 6 units, 1, 2, 3, 4, 5, 6, and over 2 units. C is already over 5, so 2 more would be over 7. Right? So I would have my dot right here, and this would be my parallelogram. These two sides would be parallel, top and bottom would be parallel, and D would have to be at 7, 8. Now, alternatively, we could have also had it looking like this. B and C could have been the top, and then D would have to be somewhere in here. So AD would have to have the same slope as BC, and D and C would have to have the same slope as AB, right? So if this is my slope here, up 6 over 2, then from here to here would have to be the same. So coming from C, I'm going to go down 6, backwards 2, right? So I'm already up 2. I have to go down 6, so down 1, 2, and then down 4 more, so I'm at -4, and then backwards 1, 2, right here. That would be point D, right? I was close. And then this would connect here, and this one would have to connect here, right? And that could be another parallelogram as well. So if I went down 6, backwards 2, and I started off at 5, 2, right? Backwards 2 would be 3. And if I'm up here over 5 up 2, and I had to go down 6, down 2, then I'm at -4. So D would have to be at 3, -4. So the two options here to keep this parallelogram is either D is at 7, 8, or D could be at 3, -4. Those are your two options.